Today we're going to try to find the value of the following integral between -1 and 1. Okay, the 4 here, I think it's just maybe an application. This is coming from some application, so the 4 is not going to play any role. So here we see that when we plug 1, we have a problem. When we plug -1, is a problem. And this function that we are trying to integrate is defined in this interval -1, 1. Okay, so the issue is that we see that the limit from when we get to 1 from the right, we go to infinity, and when we get to -1 from the right, so here we have -1 and 1. When we get to 1 from the left, we get to infinity, and when we get to, it's positive, when we get to -1 from the right, we get to infinity. Okay, so it should be stricter also. Okay, it should not exceed -1 and 1. So I'm just doing this one for just to see what's going on. Okay, so here this is just some explanation for so if it's finite, this area here would be finite. Okay, and we see that it gets very, very close to -1 and 1. Okay, so we expect that the value is finite. Okay, so here we have this is an improper integral of the second kind, because in finite boundaries we have infinite values. Okay, the issue is coming from -1 and 1, which are have infinite values. Okay, but we know this function here. Okay, so the issue that we're going to try to solve is that we have to to take care of both sides. Okay, so once we approach -1 from the right, and we approach 1 from the left, so we're gonna put this 0 in the middle. Okay, so let's have this integral, which is 4 minus 1 1 or 1 minus x squared dx. If this integral, if it does exist, so we will have, so the limit as we get to t to -1 from the right of t to 0 of 1 over 1 minus x squared dx plus the limit, okay, as we get to 1 from the left of this integral 0t 1 over 1 minus x squared dx. Okay, the good news is that we know a primitive of this one. Okay, we know that it's the arc sign. So here we have the limit as t goes to -1 from the right of the arc sign of x between t and 0 plus the limit as we get to -1 from the left of the arc sign of x between 0 and t. Okay, now we plug the values and we'll see what we get. Okay, so this is, we just apply the definition. Here the arc sign of 0 is 0. We're gonna have minus arc sign of t, okay, plus the limit as t goes to 1 from the left of arc sign of t minus arc sign of 0, which is 0. Okay, so now, so the arc sign, when we get the arc sign, okay, from this is, we don't have a problem now. Okay, when we get to -1 from the right, so we're gonna have minus pi over 2. With this minus, it's gonna be pi over 2. Here, when we approach 1 from the left, we have pi over 2. Okay, and therefore our integral is pi. I forgot to put the 4. Okay, so to solve this issue, we have to multiply everything by 4. I'm gonna go back and multiply everything by 4. Okay, so 4, and I multiply by 4, I get 4 pi. Okay, so my integral is convergent. Therefore, this integral 4 minus 1, 1, 1 over 1 minus x squared dx is equal to 4 pi. And therefore, it's finite. So this integral is convergent. Okay? And we see that we had two issues on minus 1 and 1, and we had to add these two. Okay? And that's how we define improper integral of the second kind, especially when we have two issues. Sometimes we have a combination of the integral of the first kind and the integral of the second kind. We'll see that, and we're going to see how we can solve that. Thank you.